Hey there, future CUET toppers. Are you ready to absolutely nail one of the most predictable chapters in all of organic chemistry? Good, because today we're taking ethers and turning them into guaranteed marks for you. Let's just dive right in.
So here's the big question, right? How do we even begin to tackle ethers? I get it. It's a topic that can really trip a lot of you up. But here's my promise. By the end of this session, you are going to have a rock-solid strategy to handle literally any question they throw at you. So stick with me, because this is all about boosting that final score.
Okay, first things first, we need to change how we look at this. Ethers, they're not just another chapter in your textbook. Nope. For CUET, this is what I call a scoring zone. And right now, I'm about to hand you the exact blueprint to grab every single one of those marks.
Look, this is why this chapter is so important. The questions they ask about ethers are so predictable. They pretty much always come from one of these four areas. You've got product prediction, especially with the Williamson reaction, then cleavage with HI or HBr, comparing boiling points, and of course, naming. Seriously, if you can nail these four things, you've basically cracked the entire chapter for the exam.
So let's rewind for a second. What even is an ether? It's actually super simple. You just have an oxygen atom that's kind of like a bridge connecting two carbon groups. These groups, the R and R prime, can be the same, they can be different, doesn't matter. But that ROR structure, that's our foundation. That's it.
Okay, now that we have that base, let's get into the really important stuff. How to name these things, and even more crucial, how to make them. You're going to want to pay super close attention here because a massive chunk of your exam questions, they come from right here.
When it comes to naming, it's pretty straightforward, but you've got to know both systems. You've got the common name, which is easy peasy. You just name the two groups and slap ether on the end. But the one CUEQ really loves is the IUPAC system. The rule is simple. Just remember this. The smaller carbon group gets the oxy suffix, and the bigger one becomes the main alkane name. So if you have a methyl and an ethyl group attached to the oxygen, methyl is smaller, right? So it becomes methoxy. The other part is ethane. Put them together, methoxyethane. You get that down, and you've just banked some easy points.
And now for the superstar of the show, the Williamson Ether Synthesis. I cannot stress this enough. This is the single most important reaction you need to know for making ethers. You will see this on your exam, guaranteed. At its heart, it's just a classic SN2 reaction. You take an alkoxide, it attacks a primary alkyl halide, and bam, you've got yourself an ether. Let's walk through it step by step.
Okay, listen up, because this right here is the #1 trap they set for students with Williamson synthesis. If your alkyl halide is primary, everything works perfectly. You get substitution, you get your ether, awesome. But if you try to use a tertiary halide, it's just too bulky, too crowded for that SN2 attack to happen. So instead of substitution, you get elimination. And what's the product? An alkene. This is a super important difference you have to remember.
All right, so we've covered making them. Now let's switch gears and talk about their properties. We're going to zoom in on two really high-yield areas. First, how their boiling points stack up against other compounds, and second, the one major chemical reaction they actually do, which is cleavage.
This comparison is a classic exam question, so let's break it down. When you have molecules of about the same size, alcohols have the highest boiling point. Why? It's all about hydrogen bonding. Those alcohol molecules can hold on to each other really tightly. Now, ethers, they're in the middle. They're polar, yeah, but they can't hydrogen bond with themselves. That makes a huge difference, dropping their boiling point. And then you have the alkanes, totally nonpolar at the very bottom. So just burn this into your brain. Alcohol is greater than ether, which is greater than alkane, always.
You know, ethers are usually pretty unreactive. They kind of just like to keep to themselves. But they do have one weak spot, like an Achilles heel. If you hit them with a really strong acid, especially something like HI, that super stable oxygen bridge, it breaks. This breaking, or cleavage, is basically the most important thing to know about their chemical behavior.
So what actually happens when this bond breaks? Well, if you use just one equivalent of HI, you get an alkyl iodide and an alcohol. Simple enough. But, and I need you to listen really closely here, this is a classic CUE trick. If the question says you have excess HI, the story doesn't end there. The alcohol that just formed, it reacts again with more HI, turning into another alkyl iodide. The takeaway? Excess HI means you get two alkyl iodide molecules. Don't forget that. All right, that's enough theory for now. Let's see what you've actually learned. Time for a quick question drill. Here's how it's going to work. I'll pop a question up, I want you to pause, actually solve it, and then we'll check the answer together. You ready? Let's do this.
Okay, first question's up. What is the product when you try to use a tertiary alkyl halide in a Williamson synthesis? Come on, think back to that big trap we talked about. Go ahead and pause right now and lock in your answer.
And the correct answer is B, alkene. If you got that right, awesome job. Remember the logic. That tertiary halide is just way too crowded for substitution, so the reaction takes the path of elimination instead. You have got to know this concept cold.
All right, question number 2. This one tests your memory on specific conditions. What's the main product when you heat ethanol with concentrated sulfuric acid at 413 Kelvin? Pause here, think it through. The answer is diethyl ether. This is a fantastic example of how just changing the temperature can completely change your product. At this lower temp, 413 K, you get the ether. But if you crank up the heat to 443 K, you'd get an alkene instead. Yeah? Those numbers, they really matter.
Awesome work on that drill. Okay, now let's pull everything together into a final revision plan. This is going to be your go-to guide in those last few days before the exam to make sure all these concepts are locked in tight.
First up, a super simple memory trick you will never forget. For those boiling point questions, just remember 3 letters. A, E, A. Alcohol is greater than ether is greater than alkane. A, E, A. Simple, right? Lock that in your brain. Next up, this right here, this is pure gold. I want you to pause and take a screenshot of this right now. Seriously, it boils down the 5 most important, high-yield facts you need for ethers. Glance over this right before you walk into that exam hall.
Okay, I need you to really focus for a second. Let's talk about the common mistakes, the traps that catch students every single year. Number 1. Forgetting that tertiary halides give you alkenes in the Williamson synthesis. Number 2, mixing up those 2 temperatures for alcohol dehydration. Number 3, and this one is huge, completely ignoring the word excess in cleavage questions. Number 4, messing up the boiling point order. And number 5, picking the wrong parent chain when you're doing IUPAC naming. Please be aware of these so you don't give away easy marks.
All right, time for a final super fast recap. If you remember nothing else, remember this. Ethers, they're ROR. Williamson synthesis, it's SN2, and you need a primary halide. Boiling points, alcohol, then ether, then alkane. And cleavage with excess HI, you get 2 alkyl iodides. Got it? These are the absolute must-knows.
So how did you do on that little drill? Be honest with yourself. Drop your score in the comments below, whether you got both right or maybe struggled a bit. It's all good. Let's see where everyone's at and help each other out.
And hey, last thing, if you're a serious CUET student and you're ready to master every single chapter just like we did today, then you know what to do. Hit that subscribe button. We're going to go through this entire syllabus together, piece by piece, so you can walk into that exam feeling totally prepared. Let's go conquer this thing.